All right, so today we're going to take a look at some of the examples from the notes. In particular, we're going to talk about finding quartiles, finding the interquartile range, and deciding whether something is an outlier based on the interquartile range. Now, we often go to find the quartiles as part of finding the 5-number summary. So we're going to do that for each of the examples in the class notes, just to get a feel for how this is going to work on tests or homework. So the first thing about finding quartiles is we begin with finding the median, which is another name for the second quartile. So this is the point where 50% of the data lies below it and 50% lies above it. Once you have listed all of your observations or your data in order, as it is here, then the median is just a matter of finding the middle value. If you have an odd number of values, then it's just the middle. If you have an even number of values, it's the average of the middle two. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. And so the median will be the middle one, or the fifth one. So 1, 2, 3, 4, 5. So the median, or the second quartile, is 8. Sometimes median is a capital M, so that would be okay too. Now we want to find the first and third quartiles. So the first quartile is the point below which about 25% of the data falls. And the third quartile is the point below which 75% of the data falls. So that's just a matter of repeating the median for the upper and lower 50%, right? If you take the lower 50% of the data and find its median, then you'll split it into two 25s. Now our habit will be to not include the median in the lower and upper halves. So when I go to find the first quartile, I'm only looking at these first 4 data points. And the quartile would be the average of the middle 2. It's the median of these 4, and so it's the average of those middle 2. So 6 plus 7 divided by 2 is 6.5 for the first quartile. The third quartile would be the median of the upper 50%. So that's the average of the middle 2. Well, the average of 11 plus 11 divided by 2 is going to be 11 again. So we have our 3 quartiles, and now the 5-number summary would be the 3 quartiles along with the smallest, or min, and the largest observation, or max. So the 5-number summary would look like the minimum 1, first quartile 6.5, median 8, third quartile 11, and max 13. Okay? So that's the first example. The second example, you had to pay a little bit of attention because the original data points are not actually listed in order. So that was something you have to do before finding the median and then the quartiles. I've gone ahead and written the data points in order. And once you do that, then we just repeat what we did in the first example. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. That means that the median is going to be the average of the 5th and 6th data points. So 1, 2, 3, 4, 5, and 6. Right, so the median, or second quartile, is the average of the middle 2. 29 divided by 2 is 14.5. So hopefully you got that from your median. And now to find the first quartile, we take the median of the lower half. The 13 does get included, right? It was part of finding the median, but it's not the median itself. So the 13 stays in our calculation for the first quartile. So I need the middle of 1, 2, 3, 4, 5 data points. That's my 11. So Q1 is 11, and here 1, 2, 3, 4, 5 data points, Q3 would be 17. And that's really the hard part of finding the 5-number summary. It's the minimum value, followed by the first quartile, followed by the median or second quartile, followed by the third quartile, and finally the maximum value, which would be 20 in this case. So in the notes, it only asks you to find the quartiles, but once you have those, then the 5-number summary is not far behind, so we went ahead and did that. Okay, our fourth example is a bigger data set. This is all of the ages when first taking office for the first 44 presidents of the United States. And these are already listed in order for you. So these are right, smallest to largest, not earliest to latest. All right, so we want to find the 5-number summary. So we've got 44 data points. That means the median will be between the 22nd and 23rd data point. So it's the average of number 22 and number 23. Now these are organized in rows of 11. So 22 is here and 23 is here, and the median would be the average of the two. So that's 54.5. And now the first quartile would be the median of the bottom 22. So that's going to be in position, the average of positions 11 and 12, right? It's an even number. So it's the average of 51 and 51. Well, the average of 51 and 51 is just 51, but I'll do the calculation to emphasize what happened there. And then finally, Q3 is the median of the upper 22 ages. Right, so we need the 11th and 12th for those ages. And Q3 would be the average of 58 and 60. So that'll be 59. And that makes my 5-number summary. Smallest age is 42. Q1 was 51. The median was 54.5. Q3 is 59. And the largest value is 70. All right, so that's my 5-number summary for the president's ages. All right. Now let's get a box plot of all of these ages, which is to say a picture of the 5-number summary. All right, so we're going to have, let me get a number line here. So we extend from about 40, let's see, go to 50, 60, 70. So remember the box part of a box and whisker plot goes between Q1, which is 51, and Q3, which is 59. So that looks something like this. Right? 51 is about here, 59 is about here. We put a line in the middle where the median goes. So that's going to be at 54 and a half, so right about there. And then the whiskers extend from 42 to the Q1, so about there, and Q3 out to 70. Right. I like to make the little vertical bar here just to kind of emphasize where it ends. I think the text in a lot of software will leave that little mark off. It doesn't matter to me whether you put it in or not. Now, we have to be a little bit careful when we do our box and whisker plot, because if we have outliers, it'll look a little bit different. So we're going to use the interquartile range now to check for those outliers. So the interquartile range is how far from Q3 to Q1. So Q3 is 59, Q1 is 51. So the interquartile range is 8, and that means that the middle 50% of our data falls in a range of about 8 years. Now our outlier criteria, one of the criteria for detecting outliers is the interquartile criterion, which says we look for points that are more than 1.5 times the interquartile range. So the 1.5 times the interquartile range number is 12, 1.5 times 8. So we need to figure out now, do we have any points that are more than 12 below the first quartile? And if we do, those are outliers. And also, do we have any points that are more than 12 above the third quartile? So we take Q1 minus 12. That's my 51 minus 12, or 39. This is our cutoff for whether we would consider something an outlier or not. Anything below 39 is an outlier. But notice we don't have anything like that. Right? The youngest person was 42 years old. That's more than 39. So we'll leave the whisker as it is. It extends to the minimum value, and there are no outliers to mark. What about on the upper end? We would consider how far is Q3 plus the 1.5 times interquartile range. That would be 59 plus 12, or 71. So any age above 71 would be an outlier, but similar to the cutoff for the youngest age, we don't have any ages above 71. So we don't have any upper outliers either. And so we would leave that whisker as it is, and we would be done, right? So we have no outliers in either direction. The box and whisker plot remains as it is. And just to sort of remind you what happens if you did have an outlier, like let's say we had a 79, and it turned out to be an outlier, then we would denote that with an asterisk way out to the right, and then the whisker would just go to the first, or sort of the last non-outlier version, or point, you should say. All right, so the interquartile range provides one way of detecting an outlier. In the next video, we'll see a second way, which is based on the standard deviation.